This video demonstrates adding turning movements as input demand to a simulation project. For this example, we'll be entering AM and PM peak hour volumes, and we'll focus in on two locations in our study area. First, at an intersection at Bethel Road at Olentangy River Road, and second on a freeway, State Road 315, northbound from North Broadway to Bethel Road. We'll start by focusing in on the intersection. This is node number 4 in the simulation network. So to create the turning movement table and start adding data to it, we'll go to the sidebar, Intersections tab, select Edit Turning Volumes, and click on the node. We haven't yet created a turning movement table, so we need to pick a location and a name. So we'll go to the Inputs subfolder and call it Peak Hour Volumes. This is confirming that we would like to add this turning movement table and the volumes that we'll be adding to it to the project settings. So it's just simply saving us the step of manually adding the table into the project settings after the fact. This shows us the turning movement data fields. When you create a turning movement table from scratch, there's only initially one data field, and it's called volume by default. This is where we'll be adding the separate volumes for AM and PM peak hours and specifying that those two different data fields be used in the AM and PM project scenarios. So we'll come back to this later. Typically, you would establish the data fields for all scenarios at this time so that the data for all periods can be entered simultaneously. For the purposes of this video, we will illustrate the process in steps, and you will see that the data fields can be added or renamed at any time. Before we actually start adding the volumes, it's important to understand just for a moment the difference between the volume formats available. There's two options for this: single period in vehicles per hour and multi-period vehicles per interval. We're going to use single period vehicles per hour in this case, but it's important to understand when you might want to use multi-period. In the single period format, the volumes we enter are assumed to be hourly. So the simulation period itself could be 15 minutes, it could be 30 minutes, it could be 2 hours. The volumes we enter will stay at a constant hourly rate. So if we were entering single period vehicle per hour volumes in a 15-minute simulation, the actual number of vehicles entering the network would be 1/4 of what we enter. On the other hand, if we were using the multi-period format and we wanted to run a 15-minute simulation, the number of vehicles we enter would be simulated in that 15 minutes. So it would be 4 times too many vehicles as we want. With multi-period volumes, we can specify multiple data fields to represent separate time intervals. So in many cases, we might have 4 periods of 15-minute intervals for a 1-hour simulation, and we would specify different volumes corresponding to that specific 15 minutes at each interval in terms of the total vehicles, not the hourly flow rate. So for this example, because the volume forecast sheet is displaying the hours in terms of hourly flow rates, we use single period. If we wanted to use multi-period, we would set number of periods to 1, the interval to 60 minutes, and it would be doing the exact same thing. So now we see the turning movement data editor window here, and the movements are grouped according to their approach, or to be more specific, their upstream link. The rows in the table correspond to the receiving leg of the intersection, or to be more specific, the downstream link. So we'll go ahead and enter the AM peak hour volumes initially. If this option at the bottom is checked, you'll notice that anytime you enter a number in the volume fields, it will automatically switch to the next row, and when you enter a number on the last row, it will rotate over to the next approach of the intersection, so it just saves a few keystrokes every time. So now we've entered the AM peak hour volumes for all 12 movements. So we'll close out, and now we'll go back to the sidebar intersections tab and select this option on the right for add and remove data fields. This is the same window we saw before. So the volumes we just entered are under the volume data field, but we want to be more specific and name it 2040 AM, so we know that it represents the AM peak hour. Now we'll add a second field and name it 2040 PM. Close. And this is just confirming we still do want to use that same field we were entering data for, now that it has a different name. Just beneath those options on the intersections tab of the sidebar, we see that there's two drop-down lists beneath data fields. We can now choose 2040 PM for the second field. So what this does, it just adds a third column to the turning movement data editor, and now we see on the map, annotated for each movement, there's another number in parentheses. So we can add as many data fields as we'd like according to however many time intervals are in the simulation period, but only 2 can actually be displayed on the map at once. So that's why there's only 2 drop-down lists here. So now we'll go ahead and just enter the PM volumes here. Okay, now that we double check it looks good, we can close out here. And now we'll head over to the freeway facility. Entering volumes on a freeway facility is essentially doing the same exact thing we just did. In fact, it's even simpler because there's only a very small number of movements we're entering data for. The challenge, as you'll see here, is just making sure we're transferring the given forecast volume data correctly onto the turning movement data table. So as you can see, the arrow drawn annotating the movement on the map extends the entire stretch of the freeway, which can be a really long distance if the ramps are spaced out further. So it may be a bit misleading because we see this arrow extending pretty far along downstream of the merge node here. But what it's representing is the amount of traffic that originated from this part of the freeway and then entered the merge area here at node 16. So when we're looking at the forecast volumes, we're not actually entering the downstream combined mainline and merging traffic volume. We just want actually the upstream traffic before it enters the merge node. So we want 3,550. $5,570. And then we'll head further north to the diverge node to Henderson Road, node 18. And it's the same idea here. It's just like a mirror image. It's in the opposite side we need to look at. This arrow representing the mainline traffic stretches all the way back to the Broadway merge ramp. But what we actually want is only the traffic that passes node 18 and stays on the freeway and doesn't exit. So again, we don't want this number that describes the traffic combined, mainline and exiting traffic, just this number here that represents the traffic going northbound that did not exit here. So on to the last area. This is what the HCM would describe as a weaving section, with the merge node here at node 20, and then the diverge node at node 22 here. You don't have to do anything to explicitly define this as a weaving section. What needs to be the case, or the conditions that need to be met, are that the links representing the ramps, so we can query both of those holding shift so we get two of them shown. These should both be ramp class, and of course the freeway link should be freeway class. We should have already have this set in place when we do the road editing, and then there must be one continuous lane that connects the on-ramp to the off-ramp directly, so you don't need to make any lane changes to go from ramp to ramp and make that movement. As long as those conditions are met, TransModeler will already have recognized this as a weaving segment. So we go back to edit turning volumes and select node 20. We can see there's actually 4 movements that we're entering volumes for, not just two movements as we did at the other merge ramp, because we're specifying the number of vehicles that stayed on the freeway, started and stayed on the freeway, started on the freeway to the ramp, etc. HCM Chapter 13 is the weaving methodology. If you're familiar with this, these are the variables that describe these exact movements, with the subscripts describing the upstream and downstream ramp or freeway that the movements are weaving between or not weaving between. So it's the same idea here as before. You just have to be careful about where this arrow is drawn, and because it's so long, it's a little bit difficult to see when we zoom out where exactly that arrow is showing a path to and from. So this looks like the freeway to freeway movement here. So this is VFF in the HCM terminology. And on the forecast sheet, we have the total volumes on the links themselves, and then off to the side here it shows the weaving movements that represent those four movements. So we'll just enter those here. This is the freeway to ramp movement. This is the ramp to freeway movement. And then this is usually the lowest demand movement, ramp to ramp flows. So 20 and 30. Okay, so we're done editing the volumes and entering data into the turning movement table. And this whole time we've been in the AM peak hour scenario. So what we need to do is open the project settings window from the simulation tab, and we'll just double check that in the input tab for the AM peak hour, we'll select the peak hour volumes turning movement table that we just created and added data to, and select trip table settings. And as we confirmed before, we want the flow field, which is a term that also describes the data field. Those two terms can be used interchangeably. They're describing the same thing. It's just a column in the turning movement table. We want this to be 2040 AM, and what we'll do now is select add a scenario and name it PM peak hour, which will create a copy of the AM peak hour scenario, and we'll go to the trip table settings and designate the 2040 PM flow field as the data field that will provide the volumes that are being simulated in the PM peak hour scenario. The start and stop times, as well as the output folder for the PM peak hour scenario, should also be adjusted. There's other programs that are HCM applications like HCS, where the PM peak hour and the AM peak hour analysis would have to be entirely separate files. So if you make any change to the roadway geometry, for example, both files have to be updated. But in this case, both scenarios are using the same simulation database, so all of the same geometry and the same turning movement table. They're just reading from two different data fields in the turning movement table.